Hello again, I'm back. Foundation level, section 9.2, page 120, the rules of indices. Now, question 1, it starts at grade D. By question 2, you're hitting grade C, alright? So I'll do quite a lot of these, I think, but it's probably going to be a short video. Here's the first one. It says, write in index notation. What does that mean in Walthamstow English? It means powers. Write it as powers, alright? So here we go. I've got 5 times 5 times this. I can't do 5s very well. Another one? Oh, that would do. It says 5 times 5 times 5. Write it as a single power equals 5 to the power of 1, 2, 3, 4. Alright? So working backwards compared to the previous video. Next one. What does 13 times... I'm not going to do them all. 13 times 13, what does that mean? 13 to the power of 2. But that power of 2, of course, has a name. It's called squared. Alright? Let's budge over a bit, get in the middle. Here's another one. I've got 12 times 12 times 12 times 12. Write it in index notation or in power form. I've got 12 to the power of 4. That's what that means there. So, I'm happy with that. And if it works for numbers, it works for letters. P times P times P times P. Well, if it was a number, you'd call it P to the power of 4, wouldn't you? But it works for letters. So as well, not a problem. And I'm not going to do the last one, far too many S's. Right, question 2. Working over this side. Work out the value of each of these. Here we go. 7 squared means 7 times 7. You know that. And therefore 49. Jump over a couple. I've got 1 to the power of 5. Ooh dear. Is it 5? Is it 1? Is it nothing? It's 1 times 1 times 1 times 1 times 1 is 1. 1, 2, 3, 4, 5. Yeah. You can have billions. Yeah, 1 to the power of 1,000 is still going to be 1. How about this one? Minus 3. The bracket is supposed to help. It doesn't really. Minus 3 squared. That means minus 3 times minus 3. You should remember that minus times 1 is a plus. Therefore the answer is proper 9, not minus 9. What's 10 to the power of 4 mean? Well, that means 10 times 10 times 10 times 10. In other words, what's that? 10, 10, 10, 10. There you go, 10,000. Alright? And I'm going to do 4 to the power of 3. Again, you've got to be able to work it out with that calculator. 4 times 4 times 4. Well, 4 4s are 16. Times 4 again, 64. Or simply learn it. And can't bother with that one. Now, question 3 is definitely grade C. Use the rules of indices. That's the plural of index. Indices is the plural. It's not an English plural. It's a Latin plural. Hence, not indexes, indices. And simplify the following. Here we go. I've got 5 to the power of 6 times 5 to the power of 2. In other words, I've got 6 5s all multiplied together, and then multiplied by another 2 5s multiplied together. Altogether, I've got 5 to the power of 8. So the simple rule is, you take the 2, you take the 6, add it to the 2, and you've got 8. So I've got a little plus there and a little equals. You don't have to show this in the exam, honestly, but this is what your brain should do. 6 plus 2, power of 8. Provided, of course, the base number is the same. Otherwise, we're playing with different numbers. Here's another one. I've got 12 to the power of 8 multiplied by 12 to the power of 3. Well, 8 plus 3 is 11, so it's 12 to the power of 11, and that means 12 times 12 times 12, 11 12s all multiplied together. Alright, what else have we got here? I've got here a little division one. I've got 6 to the power of 5 divided by 6 to the power of 3. Now, those of you who know me know I hate this little share sign. It's really, really ugly and can confuse you. Better to go like this. 6 to the power of 5 divided by 6 to the power of 3. Now the answer is 6 to the power of 2. When we divide with numbers, common numbers with different powers, you simply subtract them. So 5 take away 3 equals 2. Again, don't ever write that in the exam. It's a complete mess. It's just what your brain should do. Now let me prove it to you. 6 to the power of 5. Here we go. 6 times 6 times 6 times 6 times 6 divided by 6 times 6. Is that okay? And what I'm going to do now, take my red and say, well, 6 divided by 6 is 1. Good night. 6 divided by 6 is 1. Good night. And I'm left with 6 times 6 times 6, all divided by 1. Answer 6 to the power. Oh, I've got another one. Sorry. Oh my goodness. Let's just go back again. So times 6, and going back to red. Good night and good night. Okay, so 6 over 6 is 1. I'm left with 6 times 6, which is 6 to the power of 2. Let's make it look like a proper little 2. And that, my friends, matches what I said over here. So that's the proof, and you never need to do that unless they say to you, explain why. And then you've got to show all that cancelling down. Right. Do not be frightened by this one. 11 to the power of 5, and then I'm going to power up to the power of 4. Well, this means 11 to the power of, well, guess. 4 5s are 20. I'm going to prove it to you in a minute. I should do that because I'm teaching. Why is that? I've got 11 to the power of 5 times 11 to the power of 5 times 11 to the power of 5 times 11 to the power of 5. There you go. Power of 4 means I've got 4 of the same all multiplied together. So 11 to the power of 5, 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 that's 11 to the power of 5 to the power of 4. So instead of going through all that rigmarole, writing it all out crazy like, just go 5 plus 5 plus 5 plus 5, 11 to the power of 20, which is what it says over here, and 5 times 4 makes 20. That's where I'm coming from. So if you get a little bracket, just multiply the power by the power, and you've got the final power. Right, question 5, let's just turn over and do a couple of these. And then we're going to move on. Question 5, here we go. Simplify the following. Dead easy. If it works for numbers, it's going to work for letters. X to the power of 6 times x to the power of 2 is x to the power of, guess what, 8. Have a mark. Next one, e to the power of, I can't see, 8. E to the power of 8 times e to the power of 3 makes, well, e to the power of 11. 8 plus 3 is 11. If you divide, apply the same rule as you did with the numbers. 8 to the power of 7 over 8 to the power of 3. Well, 7 take away 3 is 4. A to the power of 4. And finally, do this last one here. I've got b squared and then powered up to 5. Remember, that's going to be 5 2's, b to the power of 10. Sorted. Boring, 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 but I will release this to you. Look, any number to the power of 0 is 1. And if you can be bothered to look at question 6, Adnan writes a certain little sum involving some algebra, and he therefore concludes that a to the power of 0 is 1, or x to the power of 0 is 1. Any number to the power of 0 is 1. Let me just prove it to you, then I'm going to sign off and maybe do some assess questions. So look at this. Let's have a look. I don't know, 2 times 2 times 2 divided by 2 times 2 it's just an example, right? I've got 2 to the power of 3 upstairs divided by 2 to the power of 3 downstairs. I have got 2 to the power of 3 take away 3, 0. But look at all this. 2 divided by 2 is 1. 2 divided by 2 is 1. 2 divided by 2 is 1. 1 divided by 1 is 1. So 2 to the power of 0 equals 1. And I could have used any number there. I could have had 5 lots of 6's up there. I could have gone 6, 6, 6, 6, 6, 6, all multiplied like that, divided by 6, 6, 6, 6, 6, all multiplied like that. We'll just have another one. Cancel it all out, and I'd still get 1. Why? Because 6 to the power of 6 divided by 6 to the power of 6 is going to be 6 to the power of 0, and there it is again. Any number to the power of 0 is 1. So therefore, will you now go away and learn this golden rule? If it comes up in a crafty AQA exam, then you'll be ready to nail that one. Alright? So I'm going to stop, and that's good enough. And we'll see you in the assess in probably about 4 seconds time.